everyone. So thank you very much for joining this webinar. And as all of you know, this session is something we'll be talking about what is PySpark, where that agenda of this session will be, where we'll talk about something called what is PySpark, what are the advantages of learning something called PySpark, and what are the ways we can install Spark or PySpark, which is one of the processing engine that can help us to process the data on distributed systems, and what are the fundamentals that you must be knowing or aware of. How do we deal with the PySpark, and what are the things that you must be knowing now? So as part of this PySpark, and what is the Spark as an ecosystem? So as all of you know, for those people who are not aware of what is a Spark, Spark is a processing engine where that can help us to process the data on top of any distributed file systems. On top of any distributed file systems. When I talk about a distributed file system, there are multiple distributed file systems which are available like Hadoop, HDFS, or Mesa, or something like that. Okay, so now as you could see, Spark is something one of the processing engine which is used to process the data on every processing system that way, any distributed systems. Okay, so now as you can see, Spark directly provides multiple libraries. So, okay, Spark directly provides multiple libraries that can help us to that can help us to implement some of the processing systems, especially when we talk about batch processing, when we talk about something called streaming, and when we talk about machine learning, implementing ML algorithms, or we can also make use of this graph program processing. Okay, so instead of you writing or start writing all the algorithms and everything from scratch, you will be able to make use of these Spark that can help you to process the data either using the SQL statements, either if you have some real-time data which will come up, you can also make use of it. And if you want to implement ML algorithms, you can also use it. And of course, considering that Spark as a processing engine, which is being implemented using a programming language called Scala, it is very difficult for people to process the data or write a logic using Scala, because learning a programming language like Java or Scala is pretty much difficult for most of the people. And considering that a lot of people are moving towards something called Python, which is one of the easiest programming language to learn, right? One of the very easiest programming language to learn, and we'll end up with using these streaming libraries and other libraries that can be leveraged to process the data. Okay, so that most of the users can adopt to PySpark, because even though Scala is being built with the native version, which means Spark itself is built with a native version called Scala. Instead of learning Scala, you can just start learning Python so that you can implement most of the things which are implemented using Spark, and that's the advantage that we'll end up with getting PySpark. So as all of you know, so Spark is open source community, open source processing engine, which is where people can make use of it. And Python is also one of the general purpose high level programming language which is created. And combining both together, and there is a library called PySpark which is created instead of using Scala. Okay. So what are the advantage of going for Spark with Python? So what are the advantages that we'll get? It is very easy to learn and simple APIs, are very straightforward APIs you'll be able to notice, and you can code in a Python, so that will give you all the advantages of understanding the code in a very easiest way. And availability of visualization, you can also start visualizing your APIs and DAGs and everything very easily. And it's a very Python, obviously, since you are integrating with Python, it will have a huge amount of libraries which are actually created, and Python has got a huge amount of community. Okay? Python has got a very huge community that can help us to do a lot of activities. Okay, so that is about what are the advantages that we have with PySpark. Okay, so what are the ways that we can install PySpark? Okay, what are the ways we can install PySpark in our machine? So whereas in case if you want to install PySpark, what we can do is, so spark.apache.org. So if you go to spark.apache.org.downloads, and you can see, you can select any of the Spark versions, right? And in the way how we have something called multiple versions which are associated based on Spark version and other things. You'll be able to make use of those Spark versions that can help you to use. So download those zip versions. Okay. So in using those zip versions, you'll be able to install. You can see there are commands which are given. You can make use of these commands. You can start installing PySpark in your cluster, which is very easy. Of course, in case if any one of you wanted to install something called other activities, especially like you want to install something called HDFS and everything, you can also refer to Cloudera web page. You can also refer to Cloudera website where you end up with getting a free VMware as well, which is also free gift. Okay, so there is also one more option that you can make use of that can help you to install all these things as well in case if you okay. So here, and while you are going through all these things, all the options are available for you to work on a single node machine. But please understand, when we move to Edureka, when you're going to learn, you are not going to work on this single option, okay? So which is used for something called in a local machine, okay? So you will have a fully distributed cluster given for you as a cloud lab, which means you will be receiving a cloud lab details, okay? That where you will end up with working in a cloud lab environment which has got all the way how you're going to work in real time, right? So right, so whatever the way you'll end up with working with in a real time, and you will get the same access, similar access, which is installed in AWS. And you, instead of using this free versions and everything, this may be pretty much like if you, any one of you wanted to use it as part of your normal practice purpose, you can use it. But this is not the way how actually you're going to work, because in real time you should work with a cluster which has got a number of machines installed and everything. And of course, to give you the actual feel of how you're going to work in real time, Edureka will end up with providing a cluster, okay, which where you'll end up with getting the cluster access, where you'll be able to practice all the things how you're going to work in real time, okay. And of course, all the projects, all the hands-on experience, hands-on practices, everything you'll end up with doing it with respect to how you're going to work it, okay. So that will happen by default. So that will be disadvantage when you choose for these options. You'll feel that okay, you're working in a real-time project, okay. So and that's about how things will work. So when we start working with with the Spark, basically Spark will work on a master and a slave architecture. It means you'll have something called a driver node, and you'll end up with having something called worker nodes, which means it was like a master and slave architecture, where the moment that you submit a job and your Spark context will get created. And using the Spark context, Spark has introduced a API called RDD, which stands for Resilient Distributed Data Set. So resilientness means that whenever you create any object as a resilient, and in case of any failures that happens, which your resilientness will automatically take care of that process to rebuild that particular data, okay, which will automatically rebuild the data, which will be taken care by your so-called your Spark itself. Even in the distributed file system, if any of the part page block of the data which has got some issues, and those kind of things will be taken care by your Spark itself, okay. And which is what you will end up with using, which is RDD, and where RDD provides a wide variety of APIs that can help you to implement or process the data on distributed systems, okay. Like if you want to apply group by, if you want to apply a number of things like adjoints and everything, instead of you dealing with something called all the failures or iterative process to write or to process the data on distributed systems, and your so-called files itself will take care of broadcast, accumulator, such activities, and you'll end up with noticing all those things as part of your process. Okay, and of course, we'll be learning all these things in detail. What is this process and how these processes everything will work. Okay, and we also have a few other concepts like Spark features, especially when we talk about something called Spark configurations and how the multiple Spark contexts can be created, and how to deal with the Spark files, especially when we want to deal with some other Spark files, especially when we have different file formats of text input format, or either something called Parquet formats, ORC files. Like we'll end up with learning all these different file formats, or either Delta later. So these are the advanced concepts that most of the organizations are using, and you'll end up with learning all the concepts in detail along with the practicals. Okay, so now of course we also have one of the most widely used data type or API called data frames, with which you will be able to leverage using your Spark SQLs as well. Okay, in case if you want to start writing some of the SQL commands and everything, Spark also provides something called a data frames. You'll end up with using the data frames in Spark, so that you will be able to use the schema associated with the data. That can help us to create a data frame and create something called SQL commands and everything on top of it that can help us to do this activity. And considering that, PySpark will also work on something called in-memory processing. You might have to deal with something called a memory level configurations, or either store the data on um, something called only in memory, or either something called or at least something called or spill the data onto the disk if the memory is not enough. Likewise, you'll end up with using such activities in your data. Okay, so likewise, you'll have all these concepts associated with your RDDs. Okay, and that's what you end up with noticing. Okay, so as I said, so RDD stands for resilient distributed data set. Resilient stands for rebuilding the feature in case if something fails. And distributed means that it will be obviously you'll end up with processing the data in distributed manner. And data set will have primitive values of all the data which contains all your data which is associated with your RDDs. Okay, so there are RDD will provide a number of transformations and actions, where that's what we transformations is nothing but we call it as lazily evaluated transformations, and you'll end up with having map, flat map, joins, and etc. etc. And we'll have actions also which can help you to invoke your transformation based on whatever the type of transaction that you get. Okay, so likewise we'll end up with having multiple activities, and along with that, I said accumulators, broadcast accumulators, which are also some of the other APIs which are RDD as well provides. Okay, so likewise, that's what we'll end up with using such activities, in order to work with Spark configuration. Along with that, we can also control how much of data which is required, how much of amount of memory which needs to be used by your particular job. We can also provide such inputs also using Spark configurations, which means in your entire cluster, you don't expect a particular job to use all the information, right? So maybe you might expect that Spark, if I'm submitting a particular job, I want this particular job to use a limited amount of resources instead of using the entire cluster. Because at time in production, you will end up with implementing hundreds of jobs, not just tens, right? So you not enable all those capabilities, and we'll end up with using these Spark configurations, which Spark itself will help us to control all these activities very easily, especially to process the data on distributed systems. And that's where we will end up with using the Spark configurations. Okay. So coming to the Spark files as well, as I said, so we have different APIs that can help us to deal with the different file system, file processes, and that's where we're not using Spark files as well. Different type of file formats can also be supported. Spark will also support them as well. Okay. So as I said, so we also have an API called data frames that can help us to create immutable operations. Say we can still apply the transformations and actions on top of the data that can help us to use or implement lazy level evaluations and distributed, which works on distributed systems as well. Considering that Spark data frames will have the data as well as the metadata, you will end up with using the writing very easy data frame APIs and everything that will help us to do a lot of activities. Also, you can create a data frame on top of your different data as well, RDBMS system or Cassandra, if you want to read a JSON file into a data frame. And you can also do such activities which Spark data frame will provide all those options. As I said, so storage level also can be changed. Disk and memory serializations can be applicable, and replications can also be taken care in order to provide more availability of the data. Okay, so these are the different options that Spark automatically provides. Okay, as which are built-in APIs that can help us to process the data, huge volumes of data, very faster as part of processing the Spark data. Okay, yeah. So one of the other biggest advantage going for Spark will be, especially when we talk about a distributed file systems, where Spark is the, maybe I would say, one of the open source community which provides multiple data frame related APIs to implement most of the machine learning algorithms, or not all them, because it will take some time for people to contribute for the open source community, and you end up with using Spark, which provides Spark heavily provides most of the algorithms like decision trees, random forest, all such things which will be provided by Spark. And that's what the major advantage if you go for Spark MLab. And of course, even though there are some of the other libraries which are also available like Mahout and everything, and Mahout, they are also identified that Spark will give even more benefits compared to their processing engine, which typically uses a typical map-reduced way of dealing with things. But even though they also started in integrating with Spark, that's where you can understand that how famous the Spark has become, how powerful Spark has become. So that's where you can also implement some of the ML algorithms, and by using some of the advanced ML algorithms like decision trees, random forest, they are also being provided by Spark, right? So where Spark also provides some of the workflows where we can create some kind of pipeline activities, where you can build the pipelines which can help you to take multiple steps in a sequential manner, because you will end up dealing with multiple activities when you talk about something called PySpark, like data pre-processing, data cleaning process, data feature scaling, because you will end up dealing with multiple activities when you deal with the machine learning, and you can create a pipeline that can help you to process the data in optimized manner, instead of just like that executing the transformations. And Spark provides all those options like a pipeline creations and multiple multiple pre-processing steps also, which has been taken care by Spark Emblem itself. And that's the major advantage that you'll also have by getting. Okay. Okay. And of course, those things can help us to process the data even more faster compared to the typical execution of your normal pipelines. And as I said, there are multiple algorithms which Spark Emblem provides, like clustering technique as part of supervisor learning and unsupervised learning, like linear regression, logistic regression for classification. And you can also use some of the linear algebra APIs which Spark Emblem directly provides as part of pre-processing and everything, which Spark Emblem libraries provides all of that. Okay. And apart from that, Spark also will provide streaming APIs as well, and you'll end up with using Spark streaming, which can be integrated with multiple streaming APIs, especially the messaging APIs, like the Kafka and everything, which can also be used by Spark. Okay, and of course, Spark directly provides multiple APIs, like integrating with Kafka and other things. And most of the, or either if you want to deal with something called Twitter as well, you'll end up with dealing with such activities. Okay. So now, just to show you a glimpse of how the things will end up with, you'll end up with using it. So what I'll do is I'll just go to one of the practical cloud lab. I'll just show you what are the things that you'll end up with seeing as part of your cloud lab. Okay. So I'm going to log into the Edureka cloud lab, which you will end up with getting that. Okay. I'll show you what are the clusters and how do you deal with those clusters and everything. Okay. Let me quickly show you that. So if you log in into the cloud app, you'll end up with getting all these options, right? You'll end up with getting all these options. You can go to your Cloudera manager portal, and you can provide all your, you'll end up with getting user ID and access and everything. And you can see this is the cloud lab which is given. Okay, so this is the cloud lab. If you see here, and you have a CDH Cloudera Hadoop distribution version, and you can see this is the entire cluster which you'll end up with getting, which has got a 7-node cluster as of now. So it depends on the load, and where you will also notice that this is enabled on cloud, right? So which is also enabled with auto scaling options. If more number of students are practicing, you'll notice that okay, the cloud size of this cluster will go up to 20 nodes as well. And since there is a little load applied because it's a weekday, right? So less number of students will be practicing the things, and you'll end up with seeing less amount of load applied on the cloud app. So if you want to connect to any of the services, especially if you say, for example, if you go back here, and multiple things are included as part of Flink is installed, HBase, HDFS, Hive, Vue, Impala, Kafka. You can also see Spark, which is also installed, and that's where you end up with seeing that these are the multiple resources which are available, and you can practice any of these things, so you can make use of. You can also see the okay, of course, needless to say, considering that once you got the access to this Cloudera file, Cloudera lab, and of course you can continue to use any of this. It's not that okay, hey, you're going to learn something called PySpark, where you will be given with access to only Spark, and you will be given access to the multiple things as well. And you can also practice in case if any one of you are interested to learn other things as well, you can also make use of it. And that's the advantage that you'll end up with getting. Okay, some people will say I want to practice something called HBase, I want to practice something called Kafka. Even though you haven't opted for those courses, you can still you'll be given with that particular access as well. You'll be able to still practice along with the implementation of your. Okay, that's the advantage that you'll get along with. Okay, so in case if you want to start working with, for example, if you want to use something called any of the executions, say for example, I'll go to Jupyter Hub. Okay, let me just quickly process one of the sample data. In case if you want to, I just have one of the simple example which is given. Say for example, if you want to implement some of the word count, for example, so there is also already a lab which is given. So where if you see, for example, if I'm going to use something called a simple RDD, so let me open one of the data frames example. Okay, so I have some of the files which are already uploaded in Spark. Okay, so which means in my HDFS there is already some files which are available, and you will end up with using these APIs. Okay, so in case if you want to start creating any data frames or anything, just see here I'm going to create a Spark context which is running in, I can see it is running in a, even though it is available, so this is running in our cloud lab. Okay, you can see I'm going to create a data frame which is provided here, so I'll end up with creating or enabling Spark API. Okay, so now you can see I'm creating a user ID, which is nothing but I'm creating a Spark API, which is nothing but a Spark SQL. Okay, so now here this is where I'm going to create a Spark instance. You can see I'm going to create a Spark instance, and that's what I'm trying to execute. It will take a couple of seconds to process. So let it get created. So once this is created, you can see that I'm trying to read any of these files. There are multiple files which are available: employee.json file, employee.csv, or department.csv. These are all the multiple files which are placed already in my HDFS location. Okay. In case if you want to deal with it, you can see that this is what the file that I'm referring to. This is one of the simple functions I created that can help us to refer to my user ID, which is stored in the HDFS. Okay. Now you can see I'm trying to read this employee.json file. Okay. So using this spark.read.json. Spark.read.json is one of the API which is given, where Spark that can help us to directly read this data which is available, where you'll end up with creating a data frame on top of it. You can see if you use an action, so data frame dot show is an action. By enabling this action, it will end up with executing this transformation, which means spark.read.json is a transformation. Show is an action, which means I'm creating this action on top of it. When show means nothing but it will show you the data. I'm up just for us to understand this data in a very simple manner. I'm just creating a sample data, because if I use something called very huge volume of data, this session will take very longer time. And to save some time, we're just using sample data. Of course, considering that if you have 100 GB of data or 10 GB of data or 1 GB of data, you will end up with using the same code. Okay, that's the advantage. And now if you see, you can also apply some commands like in case if I wanted to execute some other data frame API. Say for example, if I want to extract some column, say for example I want to extract only the some salary of a person, I'll be able to do such activities. Or else if I want to give some hike to a person, you can see I'm writing a data frame APIs. I'm selecting what is the employee age of the person, employee name, and then I'm creating a 1.05, which means I'm creating a revised salary of a person. So by writing this such a simple queries, which is as I said, so you'll end up with getting this simple APIs that can help us to process data. Okay, so how likewise you'll end up with executing all these data frame APIs that can help us to do. So now if you see here, I'm adding a new column on top of this data frame, and that's what you'll be able to notice. Okay, okay, let me open this example. So let's say I want to create some Spark streaming. It's a very basic example which is given. So for example, I'll end up with referring to this particular folder where anything which is been extracted on top of this, you'll end up with creating a Spark streaming context like this, where you'll enable them Spark folder APIs that can help you to do such activities. Okay, using which you'll be able to start processing your data on streaming applications. This is one of the sample examples that can help you to process the data on real time. Okay. Thank you. Thank you very much. I'm going to close the session. I hope to see you in any of the coming sessions. Thank you.